Yeah, it's not live stream. Okay, so let's look at quadratics in general and about the shape and about the forms that they come in. So the general form is kind of what we've been dealing with so far. The general form is your y is ax squared plus bx plus c. We see that a lot, where the y is isolated over there, and you have a, b, c, three constants. What does this tell you? And you already alluded to this. This c tells me we're across the y-axis. And the a will determine what?
Like what shape?
Yeah, the shape. Yeah. Okay. So it's quite useful. In order to get the roots, though, you'd have to factorize when you or complete the square or use the quadratic formula to get where it crosses. Okay, there's a couple of other forms. There's what I call intercept form, and there's vertex form. So vertex form, what's a vertex of something?
It's like the where it turns.
Okay, so this is the vertex, yes. The vertex is right down there at the turning point. Later on, we'll start calling that a stationary point or turning point. So vertex form you may have seen in GCSE. It's ax minus h squared plus k, if you remember. Remember that? No? Oh, no.
Our class learned did? Yeah, we did.
Who was your teachers? So who had Mr. Gide?
Me and Richmond.
They never did it?
And you,
All right, okay. Say no more. H and K is the vertex. Yeah, that bottom point. Also, there's something called the axis of symmetry of a quadratic, which is what?
It's like
You fold it. Yeah, you'd fold it. Axis of symmetry. What would be the axis of symmetry of this one? So we're talking about in general, the x value.
A. No, H.
H.
X equals K.
X equal to h would be the axis of symmetry. So where it folds. And remember, it's x equals. It's a line. It's not a point. An axis of symmetry is a line. It has to be x equals. Because all the points, one way of looking at it, all the points along this would have the same x value. It would always be x equals 3 all the way down if it went through 3 here. Okay, so if we had the vertex, so if we knew the vertex was at, let's say, 3, negative 2, the axis of symmetry would be x equals 3. Because it has to be. It wouldn't fold perfectly otherwise. Why is it negative here and then positive?
Sorry.
Why is it negative in here and then positive when it comes out?
Rearrange. Square. Move it to the left hand side.
Yeah, well, if you ended up solving it, yeah, and you had an x equals, you'd imagine that h, when it comes over, you would add it to both sides. And that's one way of looking at it, yeah. When you factorize, you always end up with the opposite sign to what the root is when you let it equal 0. Null factor law, the classic x plus 3, x plus 2 is equal to 0, then the root is x minus 3, and x, same reason as that. Okay. Intercept form is maybe a little bit new. You probably should have done it last year as well. And it has this form.
What is that? Root form.
Intercept form or root form, yeah, it can be called root form. If you'd rather call it that.
Which one's H and which one's K?
Yes. K has to be the y value of the vertex, and h has to be the x value. Yeah. So this is intercept root form, which is useful working back if you have the roots already. If you have the roots or the zeros, you can use this form and work back. Why is there an A here?
A is the shape.
Yeah. So multiple equations will have the same roots. So let's talk about one that goes through x at minus 2 and x at plus 3. So there's not just one equation that will have those roots. So there's one, badly drawn. There's one. But the shape of the quadratic could be a lot different. It could be a quadratic that's quite wide and go through the same roots. And the A will determine that, and of course its nature, if it's upside down or not. They all go through the same ones, and that's the A will determine how wide or narrow it is. It could be even narrower if you want as well. So that's why we put this A here. There's like an infinite number of equations that have the same roots. It just depends on the shape then. The A depends on the shape. So P and Q here. X equals P and X equals Q are what? Are intercepts, yeah. Or roots or zeros of the equation, yeah. And the A determines the shape. If I want to get the axis of symmetry from this one, what could I do? The midpoint or the average, yeah. So the axis of symmetry would be, oh, well, if I know these two, it's going to be halfway exactly between these two. So I'd add them up, P plus Q, and then divide by 2 to get the average or the midpoint of the two. And that would give the axis of symmetry of that. Okay. All right. We have to be able to do a few things. We have to be able to work backwards and get a quadratic when given roots. When given a diagram is usually something that's not done in GCSE level. So if I gave you a diagram, would you be able to draw the quadratic? A sketch. Oh, no, sorry. If I gave you the sketch, would you be able to write the quadratic? I'm just going to make one up. So I'm going to give you a sketch. I'm going to say this is, I'm going to give -1. I'm going to give this as 3 and this as 2. All right. Find the equation for that one.
In which form?
I want it in general form. So I want the final answer to be in ax squared plus bx plus c. Can you do that?